class today. Let me turn on my slide first. Give me one moment. Okay. Okay, let me share my screen. Okay, what have we learned last week? Can anyone tell me? Anyone? Okay, let's start my pen. Okay, let me pick someone to answer my question. What have you learned last week? Anyone? Ho Heng Dong, are you here? What have we learned last week? Hey, I'm asking Ho Heng Dong, not Lô Thông Lê là. Ho Heng Dong. Still remember or already completely forgot? E equals to HF, fair enough. Okay. What is E equals to HF? Anyone? Can you further elaborate more? Mr. Hu. Waiting for answer. So for my class, I will keep asking you the question. This is my style. Okay. So better prepare to answer every single question. Yep. Wong Chung Yi already give the answer. H equals to Planck constant. And then F is the frequency. Then how do you get F? Unless, how do you get F, this frequency? Unless, are you here? C equals to F lambda. C equal to speed of light. F is the frequency, and lambda is the wavelength. So this will obey the first rules of the quantum mechanics, where we will see as a photoresist phenomena. Okay, second one is the one that mentioned by the Lô Thông Lê, wave particle duality. Lô Thông Lê, can you tell me what is the wave particle duality? Can you elaborate more regarding this? Okay, energy equals the momentum times speed of light. Okay, in the wave, this wave particle duality, instead of just giving me all the formula, okay, Tan Shin Sen already tell me this. Okay, the light. Okay, the light will be having the wave properties and also the particle properties. Okay, so what kind of formula are we using in this second laws? Kubun Kyung. Are you here, Kubun Kyung? What kind of formula are we commonly used in this wave particle duality? Okay, KE is the half mv squared. Fair enough. What's the KE? Kinetic energy. Kinetic energy. Okay, what else? Kubun Kyung. Anything else? Yep, wavelength equals to h over mv. So to refresh your memory, P equals to h over lambda. P is the momentum equals to the mv. H is a Planck constant. Then lambda is the Broglie wavelength. So this is basically the all content that we have learned last week. Last lecture. So today we are going to learn about the third rule. Actually, there are 2 slides only, so hopefully you can emulate it fast. Okay, third rule is the uncertainty rules. Okay, the first rule is the photoresist, and the energy is in the quanta. Second one is the wave particle duality. The third rule is the uncertainty rules. What is the uncertainty rules about? Uncertainty rules means that it is impossible to simultaneously describe with the absolute accuracy the position and the momentum of a particle. That is equals to this thing. Okay, let's see what's this. So, last time in the physics, let's say if we are trying to drive a car, so maybe we can calculate the velocity, then we can calculate the acceleration, then based on the distance and the time. But this is all in the classic physics theories only. Physics theories. Okay, which will related to all the Newton's first law, second law, and third law. Okay, let's remember that. But when you are going to the quantum mechanics, when you are mentioning about the electron, if you really want to measure the momentum, exact value, it will be very hard. Okay, if you want to measure the exact time, very hard. Energy, very hard. Everything are very hard to be exactly measured. That's why we call it as a uncertainty rules. How many of you have watched the Avengers Endgame? Anyone? Do you still remember the Avengers Endgame? Okay, do you still remember in the very beginning scene when the Captain America and the team go to find Tony Stark? They say want to do the time travel. Do you still remember that? That's one scene. Captain America, Iron Man, Tony Stark is staying in the cabin. He no longer want to he no longer want to join the team. Then, when the time the Ant-Man, he's saying they want to do the time travel, then the Tony Stark say because it is a very hard thing, because it will not follow the Planck constant rules, which means that you are not going to exactly estimate where is the time that you are going to, because all are uncertainty, uncertainty, uncertainty. How are you going to expect to travel to a certain time to the exact place that they want to go to get back the infinity stone? So that's why Tony Stark did mention this thing during the movie. Okay, not sure whether you still remember that or not. You can go back to have a watch scene. Right now is the MCO. Okay, so this is what the Tony Stark actually mentioned. The time cannot be really obeyed. Okay, so this one actually related to the third rules that we are going to learn. Okay, so there are two rules. Okay, no more Avengers. Come back to lectures. Okay, two rules here. The first one, hard to, very hard to simultaneously describe the absolute accuracy, the position, and the momentum of a particle. That is, according to this formula. You can see there's a changes. The triangle means the changes. The small changes of the momentum. Multiplied by the small changes of the location. S is always the location. But he can say that the multiplication of these two items must be always more than or equals to the reduced Planck constant. This one is equals to the Planck constant divided by 2 pi. Okay, so the theory one is very hard to mention these two together. You can just give the as very estimated value only in this case. Okay, here's the first rule. Second rule is very impossible to simultaneously describe with the absolute accuracy the energy and the time. Also more than or equals to the reduced Planck constant, which is equals to this. So basically very simple, but the derivation background I won't describe it because it's too many physics. We just focus on the microelectronics, that's more than enough. But what is the significance of the unsteady principle? Which means that we cannot determine the exact position of an electron, just like what Tony Stark said, we cannot exactly determine which time or which part that we are going to go. We can only determine the probability of finding an electron at a particular position, which means that maybe when the electron travel from one part to another part, what are the probability that electron will go to the, let's say, 10 cm or 10 mm, something like that. So even in the semiconductor, or everything is in the nanometer, maybe 0.01 nanometer. Okay, how are we going to estimate the location? We just can get the probability only. Okay, so that's why in the Schrodinger theorem, okay, this one is just for your knowledge only, Schrodinger theorem. But we are not going to learn this up because this one is too complicated, too many derivation. Okay, so that's why in this case, we just need to know how to use these two formula that is more than enough for our cases. Okay, so let's see how we're going to use this formula. Okay, the uncertainty of in the position is a 12A. Uncertainty S equals to 12 times 10 to the power negative 10 meter. For the mass is always the constant lah, negative 21 kg. But this is a particle. He didn't say whether it's an electron or a proton. And the nominal energy, he have a nominal energy, which is a 16 eV. Determine the minimum uncertainty in the momentum and the kinetic energy, given that this minimum energy is equal to this formula. Okay, the first part we can do is we can use this formula like this. Okay, this one. Okay, this one is always a constant, so that's why you can know that. Okay, this is a 1.16, 1.0454, 1.054 multiplied by 10 to the power negative 34. Actually, this value, the reduced Planck constant, you can find in the constant list. It's somewhere around here. This one, over 2 pi. 1.054 times 10 to the power negative 34. Okay, then get back to here. Okay, this is, and then we need to determine the this P. But we know this one. This one we know because it's given here. 12 times 10 to the power of negative 10. So what you have to do is basically using this value to divide it by this value, then you can straight away get the minimum for the momentum. Okay, you must be having some value. So in this case, the value should be 8.787 times 10 to the power negative 26. Okay, so the first part we are done. Then what about kinetic energy? Uncertainty of the kinetic energy, which is equals to this. But he asked you to do using this formula. So we have this M. The value is coming from here to inside here. But what about this P? Okay. So this P, we can use this P equals to MV to calculate the value for us. How are we going to get this value? Okay, in the question here, it tell you that the energy equal to 16.16 eV equals to 12 mv squared. So from here, you get a V. Then P equals to MV. Okay. So M is a constant. V is calculated. Then you can calculate the P here. After you calculate the P here, so you can get the value into here. So by using this value, multiply this value, multiply by this value, you can get your final answer in here. Okay, very easy only. Okay, maybe let's try this example and see how we're going to deal with this. So basically, the two formula you need to know. Okay, before that, I print screen the thing, the constant list to you. Okay, snapshot. Notice. Okay, so basically this one is like this. Okay, pencil. Where's my pencil? Here. P S constant. And then this one is like E T constant. Okay, try this for example. Can see or not? Okay, right now, let's see what will happen. Okay, how many of you have done this question? Can anyone tell me? Okay, have you done all the question? Anyone? If done, then you type a yes. If no, type a no. Okay. Okay, have you done? Anyone? Okay, let me have a word. See how many of you have done that. Done? Yeah. And launch it. Okay, try to work. I want to see how many of you have done the question. Okay. One B. So one B basically is just something like this. Okay, it's exactly the same, I would say. Just that the value slightly changed only. Okay, you also need to use this formula. This one. Okay, Wong Chong Ye have done all the question. Looks like. Okay, let's discuss the answer right now. Okay. Okay, so let's see. First question. The answer in the position, this one, is equals to 10 meter. Determine the uncertainty of the P momentum. Okay. If the nominal value is equals to 1.2 times 10 to the power of negative 23. Okay. Then this thing, you can use this to calculate this. No problem. So the second part, determine the corresponding uncertainty in the kinetic energy. Okay. So since you are having this already, you just need to use this formula P multiplied by this divided by the M. Then M, what is M? M is the electron, size of the electron. This one, 9.11 times 10 to the power negative 31. You got a P. P is given here, times 10 to the power negative 23. Multiplied by the P, uncertainty of P, getting earlier, divided by 9.11 times 10 to the power of negative 31. Then in this way, you are able to get the answer. Okay, what's the answer? So your friends, Wong Chong Yi, you get this equals to 1.32 times 10 to the power negative 25. How many of you get this? Have you all got the same answer for this case? Or not sure? You think I'm doing wrong here? Okay. So I guess maybe some of you may get a different answer if you mention in this way. So let's see what I can get here. Okay, give me one moment. Turn on my spider. Okay, it may take a while to turn on my software. Okay, so let me get back to here. Okay, first we calculate this P, but we still need to know the Planck constant. Planck constant is already here. So this Planck I equal to H divided by 2 multiplied by math dot pi. Import math. Okay, then your x is equal to let's see back the value. S is 8a. This one 8 times 10 to the power of negative 10. So your, let's say, momentum, let's say SP, put it as SP, R divided by X. Next part, SP is 1.31 times 10 to the power of negative 25. What won't you do is correct. Okay, do you get the same answer, everyone? Okay, so good to hear this. So let's proceed to the next part, which is the calculating the energy. So if you want to calculate the energy, so we need to determine the P first. The P is given over there. P value 1.2 times 10 to the power negative 23. So the SE equals to P multiplied by SP divided by 2 multiplied by divided by, let's see the formula here, M divided by M. M is given over here. So let's calculate this. This one I not necessary. Okay, run it. Then your SE 1.7. This one is in the joule, if I'm mistaken. Okay, 1.7 times 10 to the power of 18. Okay, do you get the same answer as me? Okay, thank you, Hu Hing-dong. Then let's proceed to the next question. Okay, proton energy is measured with uncertainty of 0.8 eV. Energy 0.8 eV. Determine the minimum uncertainty in time which the energy is measured. Okay. So in order for you to do this, just use this to divide by this only. Okay. So let's see. But this one actually I already converted into the EV form, so that's why. So originally you also need to do everything in the SI unit form. Okay. So let's see this. So this is a Planck constant, reduced Planck constant. This is an energy. So let me do it here. Okay, I remove all this thing, not necessary one. Then your SE is equals to 0.8 multiplied by E. Okay. RH equals to H divided by math dot pi. Yeah. Math dot 2 pi is it? Math over 2 pi. 2 multiplied by pi. Then your T, ST should be RH divided by SE. Then you can run it as T. More 2, 3 times 10 to the power 16 seconds. Do you get the same answer as me? Okay, thank you, Hansen, for the answer. Okay, so if you can do this, then the next question also the same. Okay, since both are having the same energy level. Okay, second and third will be having the same answer because the mass actually doesn't affect the measurement anyway. Then we go to question number 4. Question number 4 is kind of direct. So you just need to use this. Okay, determine the minimum uncertainty of the momentum. Since you already know this 1.5 times 10 to the power negative 10, so you just need to divide. Okay, just need to divide only. Okay, let's see. So my SS is equal to 1.5 times 10 to the power negative 10. That's this is SP. So your SP is 7.029 times 10 to the power negative 25. Do you get the same answer? Okay, so good thing. So I think that's all for the lecture today. So for the next week onward, we will go to the next chapter. Okay, I will see you by next Monday. Thank you for your attention and have a good day. Have a good weekend. I will try my best. Okay, because sometimes I will forget too many things in my head now. Okay, I try my best. I will try to upload the lecture 2 and lecture 3 slide by today. Okay, I try my best. Okay, I'll see you next week. Bye, everyone.